Okay, you're welcome to today's class. I'll be walking you through chemistry, and we'll try to understand basic concepts in chemistry. Okay, now when we talk about chemistry, as you all know, we're actually referring to the branch of science that actually studies substances around us, the way they interact with the environment, changes that occur within them. Okay, so and these substances around us, we normally refer to them as matter. Now, for our very first topic in chemistry, we'll be talking about matter. What is matter? Okay, when we look around us, we see things, and many of them have masses. They have size. They can be big. They can be small. Some of them are rigid like stones. Some of them flow like water. Some of them evaporate or move around like air. Okay, but one thing about them is that regardless of how they are, they have mass and they take up some space. Okay, so when you look at something like a book, if a book is on a table, it is taking up a particular portion or particular space on that table. So that book is matter. But when you look at fire, okay, fire does not take up any space at all. It's as a result of heat combustion going on. So it doesn't take up any space. So fire is not matter. So anything that has mass and occupies space, we can actually say that that thing is matter. Now, don't forget, whenever matter comes to your mind, we're talking about space, something that takes up space, and that thing also has mass. All right? Good. Now, looking at it, talking about matter, we have lots of ways or lots of shapes or lots of uh, let me see how they can exist. Some of them can exist in different states. So, talking about these states of matter, matter can actually exist in solid form, solid state. It can also exist in liquid state, and matter can also exist as gases, that's in gaseous state. Okay, so we have a gaseous state of matter, liquid state of matter, and solid state of matter. When we talk about solid state of matter, we are actually referring to matter that exists in rigid form, which means it has fixed shape, and not only fixed shape, it also has fixed volume. All right. So these things like our books, stones, containers, we have trees around us, all of those ones they exist as a solid states of matter. Even human beings, we can actually say that human beings practically exist as a solid matter. Okay, so all of these are examples of a solid. So one thing I'll give you some examples. Ice, blocks around us, wooden blocks or stone blocks. You have stones around us. We have books around us. So these are examples of what? Solid. So matter existing as solids, okay? Now, what about liquids? Well, solids don't really flow, but liquids flow. So even though liquids have fixed volume, they don't have fixed shape. No fixed shape. So liquids have fixed volume, but they don't have fixed shape. So because they don't have fixed shape, it allows them to flow. For instance, we have water. Talking about water, you realize something. If you pour water into a circular container, the water takes up circular shape. Then if you pour the same water into a square container, the water takes up square shape. What does that mean? It means the water doesn't have a shape of its own. It only takes up the shape of its container. Okay? So water, we have things like vegetable oil, we have petrol. All of these are what? Liquid matter. They can actually flow on a particular plane. Alright? Good. Now, Even though they can flow, matter can still exist in freer states. Okay, so we're going to be talking about the gaseous state. Now, these ones, they don't have fixed volume, no fixed volume, and not only that, they don't even have a fixed shape, no fixed shape. And one thing about them is that their masses are even negligible compared to the container you're using storing them. So gases more like flow, but not in two-dimensional plane like liquids. They can actually flow in three-dimensional plane. So we can call it they kind of vaporize or evaporate. Okay? So examples of gases, we'll be talking about water vapor or steam. Water vapor. We have air. Air is also an example of gas. And we also have carbon dioxide or CO2. You remember, you breathe in oxygen and you breathe out carbon dioxide or carbon dioxide, as the case may be. Okay, so these are states of matter. So solid states, rigid, fixed shape, fixed volume. Liquid shape, even though they have their fixed volume, they don't have a fixed shape and they flow. Okay, now gaseous states, they don't have fixed shape and they don't have fixed volume. So even if they don't flow on plane like liquids. They are freer to move around, so they flow in three dimensions. Okay, so they actually kind of evaporate. Okay, so that is why, because of the flowing nature of liquids and gases, we actually refer to liquids and gases as fluids. So when we say fluids, we're talking about a liquid or a gas. Okay, so while liquids flow on planes, gases generally flow in three dimensions. Okay, now some of you might be wondering, why is it that we have ice here, we have water, and we have water vapor? Are they not technically the same thing? Yes, they are. Okay, but there are properties of water that makes it ice, the properties that makes liquid water, and the same properties make it what? Water vapor. Okay, which means matter has properties. And these properties can be grouped into two. Let's talk about the properties of matter. Okay, talking about the properties of matter, we have what we refer to as the physical properties. The physical properties. Now, what are these physical properties? We come in, and we also have what we refer to as the chemical properties. So, those properties that can lead to changes that we can see, feel, or touch. Okay, but it doesn't change the identity of matter. We refer to them as physical properties. Okay, so in physical properties, we are talking about density. Okay, density is a physical property because it's something that we can feel. For instance, once I carry two substances, if even with my eyes closed, and I'm told that in my hand I have a stone and a piece of foam, even if I have my eyes closed, I realize that just by feeling them, I can notice, oh, this stone is far heavier than, they're the same size, but this stone is far heavier than the piece of foam. So the density helps me to identify the stone. So it's a physical property. It doesn't change the identity. It doesn't affect the identity of a stone because the density of a stone, it doesn't tell me exactly whether this is a limestone or a granite. Okay, I just know that it's a stone, which is heavy. All right, good. Now, another thing we have is malleability. Malleability. This is a physical property. For instance, when I get a piece of wire, copper wire, I can bend it and twist it back. Okay? Now that physical property does not, bending the copper does not stop it from being copper. Putting it back straight does not stop it from being copper. So whether I bend it, I twist it, or I straighten it, it doesn't affect the identity of the copper because that malleability or drawing it into wire is what a physical property. Now, other physical properties you have is the boiling point. Boiling, the melting points, all these are just physical properties. They don't change it. That is why melting of ice to water does not stop the water from being H2O. All right? Boiling of water to become steam or water vapor does not stop it from being H2O. So it doesn't affect the identity of the water. So that's why there are physical properties, things that we can easily identify by sight, by feel, or by touch, without affecting the identity of the substance. Okay. Now, if it actually affects the identity of the substance, then it's no longer a physical property. It is actually a chemical property. Okay? For instance, when we look at charcoal, charcoal is an allotrope of carbon. Okay? But when we burn charcoal in air, in the presence of oxygen, now charcoal burns to give carbon dioxide, that's CO2, and heat. Okay? So this charcoal, it burns to give carbon dioxide and heat. At the end of the day, we are left with ashes, living ashes. So you see, this kind of change, like burning, is a chemical property because it affects the identity of the matter. You don't get the charcoal back. You are now left with just ashes. Okay? So the property of the charcoal the identity of the charcoal has been changed. The same thing, rusting. Rusting is also a chemical property because it alters or changes the identity of the substance. Okay? So when you have iron 2, now, when you have iron 2, and here you're now reacting with oxygen, it now oxidizes to give you what? Iron 3. Okay? So the green iron 2 now becomes what? Brown iron 3. You've altered it, you've changed the identity, they're no longer the same. So burning, rusting, these are some examples of what? Chemical properties. Okay? So that is that about the chemical properties of matter.